Good day. Let me present the results of scientific research on the topic the method of detection of speech process signals in the structure of electroencephalographic signals. The ability to exchange information between people is provided through communicative function, in the process of which a significant number of organs are involved that form a complex system. There is an increase in number of people with limited or lost communicative function, in particular due to dysfunction of organs or systems of a human body that perform this function. Therefore, it is important for medicine to find ways to indirectly compensate the impaired human communicative function. For this, the authors of the paper proposed a method based on synchronous selection and processing of electroencephalographic and electromyographic signals. In this case, electroencephalographic signals should be taken from the patient's head surface near the speech centers. Electromyographic signals should be selected from the neck surface near the vocal folds. At the same time, in accordance with the proposed method, in the structure of electroencephalographic signals, it is necessary to identify the time intervals of the appearance of scenes of the process of human communicative function implementation. For this, mathematical model of electroencephalographic signals was carried out. The structure of electroencephalographic signals should be shown signs of realization of the communicative function. To substantiate the mathematical model of those signals, the following assumptions were made. Areas of electroencephalographic signals at rest, in the absence of speech process with constant additional factors, will be stationary, and areas of electroencephalographic signals when patients try to say something will be stationary but with different parameters from similar areas for rest. In this case, the mathematical model of electroencephalographic signals in the form of piecewise stationary random process was used. Accordingly, the task is reduced to the task of detection time points T1, T2, Tn of the occurrence of changes in parameters of stationary sections of electroencephalographic signals. The basis of the proposed method is the use of spectral correlation analysis method and to process the electroencephalographic signals at intervals of a specified duration within the sliding window. The developed method for processing of electroencephalographic signals to detect the time moments of appearance of scenes of the speech process includes the following stages. The formation of a sliding window with a given width, which is broadcast on electroencephalographic signal in time. Within each sliding window, the power spectral density distribution of the electroencephalographic signal is estimated. Calculation of averaged power spectral density distribution estimates. On the basis of the calculated averaged power spectral density distribution estimations, the formation of a criterion for decision-making on existence of scenes of communicative function realization is carried out. As a criterion, it is proposed to use the variation of the averaged power spectral density distribution estimates, assuming that the values of a variation of those estimates for the state of rest will be significantly different from the state of attempt to implement the communicative function and will not overlap. The proposed method is described in detail in the article. The assumption is made that the averaged power spectral density distribution estimates will be indicators of the beginning and the end of the speech process. At the same time, the value of those averaged estimates was postponed at one time axis together with the original electroencephalographic signal. T-window are marked broadcasts of a sliding window within which the electroencephalographic signal was processed. Within each window, the power spectral density distribution estimates of the signal were calculated. They were then averaged over frequency and power. The obtained average estimates were plotted on the time axis in the middle of the time interval, which is equal to the width of the sliding window and the position of each individual broadcast of the window in time. As a criterion for determining the time intervals of attempts to implement the speech process, the variation of the averaged power spectral density distribution estimates is used. It was established that values of such variation increase by more than order of magnitude in the presence of scenes of increased brain activity. Accordingly, the proposed criterion is sensitive and can be used to set the time intervals of attempts to implement the communicative function by the electroencephalographic signal. The reliability of obtained results is evaluated on the basis of Fisher's criterion. It was established that the use of the proposed method of processing and criterion gives an opportunity to establish with 99% reliability the state of increasing brain activity in the process of implementing the communicative function and to detect the speech processings in the structure of electroencephalographic signals. Thank you for your attention.